This is the screencast for section 1.3, example 4. Example 4 asks us to find 3 of the 12 basic functions that are even, meaning the same on the left and the right of the y-axis. Which ones are they? 3 of the 12 basic functions. So let's see. This one is definitely not even. That actually looks odd. Y equals x squared was the example we used in describing what even symmetry was. So y equals x squared is definitely symmetric about the y-axis. Y equals x cubed is odd. Y equals 1 over x looks odd. That has no symmetry. There's nothing going on the left or the right of the y-axis or across the origin. Same with this one, the exponential function, no symmetry. Natural log function, no symmetry. Sine function, it's kind of hard to see that, but it actually does look odd because it's doing the opposite things across the origin. Every point I would create would do the opposite thing if I passed it through the origin. Any x value I plug in, the negative x value comes out with the opposite output. The cosine function, however, is even. Y equals cosine of x, that has even symmetry. And the absolute value function has even symmetry. And I can actually prove those. Y equals negative x squared. So if I plug in, well, you're used to seeing it this way, f of negative x. If I plug in negative x, a negative x squared is positive x squared, simplifies to be positive x squared, so I got the same thing, so that has even symmetry. Cosine of x, we won't mess with that until chapter 4, but here we go, y equals absolute value of x. When I take the absolute value of a negative, I get a positive value. So again, I end up, when I plug in a negative input, I end up with the same thing I started with, also even symmetry. The now try problem, number 19, for example 4, asks us to find the 4 functions that are odd. So they have symmetry opposite the origin. So I'm looking for symmetry opposite the origin. So that means it's doing the same thing like to the top right of the origin and bottom left. So y equals x is definitely symmetric about the origin. Also, if you plugged in negative x to that function, you would get out the opposite of what you started with, so that is in fact an odd function. Let's look for another one. X squared is an even function, so that's not symmetric about the origin, that's symmetric about the y-axis. X cubed does look odd though. It's doing the same thing to the top right of the origin and bottom left. And if I plug in negative x, I get, let's see, negative x cubed. A negative cubed would stay negative, so I get the opposite of what I started with, so in fact that would be also odd. Now how about the reciprocal function 1 over x? Yeah, that looks odd to me too. I know it looks like a little shorter here and a little shorter here, but remember those go to infinity, so it does look symmetrical. And if I plug in negative x for that one, I get 1 over negative x, which simplifies to just negative x without the parentheses, or 1 over negative x without the parentheses. So that in fact is an odd function as well. Wow, we're on a roll here. That's not odd because it's got nothing to the bottom left. The whole function's top right of the origin. Absolute value is even, so no. Cosine is even. It does the same thing to the left and right of the y-axis. Sine function. Maybe. That looks a little weird. I'm going to come back to that one. Natural log, no, it's doing nothing on the left side of the y-axis or the origin. E to the x, no symmetry whatsoever at that one. Integer function, it looks like maybe top right, bottom left is doing the same thing, but let's look here. If I plug in positive 1, I get positive 1. If I plug in negative 1, I get negative 1. So far, so good. What if I plug in like 1/2? I get 0, but if I plug in negative 1/2, I get negative 1. So that is not exactly opposite, no symmetry opposite the origin. It's close, and it works for some values, but not all of them. So like 1.5 would produce 1, but negative 1.5 would produce negative 2. So nope, doesn't work. And then the logistic function, it does have this kind of opposite thing going on, but it's not opposite the origin. It would look like that if it was symmetric to the origin. So no. So I'm guessing it's sine function. So let's take a look here. If I plug in what looks like to be about 1.5, I get 1. Negative 1.5, negative 1. Yep. How about 3, I get 0, negative 3, I get 0, sure. How about, what is that, 4.5, negative 1, negative 4.5, positive 1. So it is looking like that. Now I don't know enough about the sine function yet to show that it's an odd function, but because I see it on the graph, I can tell you that in the future this will be able to occur. The sine of negative x is going to be equal to the opposite of the sine of x. But here are your 4 functions that are odd. Y equals x cubed, y equals 1 over x, and y equals sine of x.